Question number 11. Last video we solved already question number 1 to 10 in exercise 10.3 vector algebra. In this video we are solving 11 to 18. So 11 question, show that magnitude of vector A into vector B plus magnitude of vector B into vector B is perpendicular to magnitude of vector A into vector B minus magnitude of vector B into vector B for any two non-zero vectors A and B. So simply you see, don't get confusion. These two vectors is there. So these two vectors we need to prove perpendiculars. Nothing but this dot product is equal to, if dot product is 0, then the given vectors are perpendiculars. So this one you take as vector alpha and vector beta. Just you find vector alpha dot beta. That is nothing but vector A, magnitude of vector A into vector B plus magnitude of vector B into vector A dot magnitude of vector A into B minus magnitude of vector B into vector A. So it is in the form of A plus B into A minus B, A square minus B square. That is magnitude of A into vector B whole square minus B square. So magnitude of B into vector A whole square. This is equals to magnitude of A square into magnitude of B square. Here magnitude of A square into vector B square. Vector B square nothing but magnitude of B square minus magnitude of B square into magnitude vector A square nothing but magnitude of vector A square. These are cancelled. This is equal to 0. So alpha dot beta is equal to 0 means alpha is perpendicular to beta. What are the alpha and beta? Given vectors. So given vectors are mutually perpendicular to each other. Next to 12th question. 12th question. If A dot A is equal to 0, vector A dot vector A is equal to 0 and vector A dot vector B is equal to 0, then what can we conclude about the vector B? You see, vector A is equal to vector B. Vector A into vector A equal to 0. Vector A into vector A nothing but vector A square is equal to 0. So magnitude of vector A square equal to 0. That is magnitude of vector A is equal to 0. That means A is the null vector. A is what? A is the null vector. Next to what they given, you see, vector A dot B is equal to 0. When the dot product is 0, here we have three cases. What is that? If A and B are perpendicular to each other, then the dot product is 0. Otherwise, any one of the vector means vector A is 0, the dot product is 0. Vector B is 0, the dot product is 0. That means here A and B, here one of the vector is 0, means vector B need not be equal to 0. Understood? Vector B is need not be a null vector. That is our answer, right? And this is the 12th one answer. B need not be a null vector is the answer. Vector B need not be a null vector. This is the answer. This is the 12th. Next to 13th one, you see. 13th one. If vector A, vector B, vector C are unit vectors, such that a plus b plus c equal to 0. That is vector a plus vector b plus vector c is equal to null vector set. Find the value of a dot b plus b dot c plus c dot a. Right? Here you take staying on both sides. That is vector a plus vector b plus vector c whole square is equal to 0 square. So it is in the form of a plus b plus c whole square. A plus b plus c whole square is equal to what? A square plus b square plus c square plus 2ab plus 2bc plus 2c. So here a is vector a square nothing but magnitude of a square, vector b square nothing but magnitude of b square, vector c square nothing but magnitude of c square plus 2ab 2bc 2ca. So 2 into vector a dot vector b plus 2 into vector b dot vector c plus 2 into vector c dot vector a is equal to 0 square equal to 0. Magnitude of a is equals to 1. So 1 square equal to 1. Magnitude of b also 1. 1 square 1. Magnitude of c also 1. 1 square 1. So 2 is common here. A dot b plus b dot c plus c dot a is equal to 0. 1 plus 1 plus 1 is 3. 3 is taken to right side. So 2 into a dot b plus b dot c plus c dot a is equal to minus 3. Therefore, a dot b plus b dot c plus c dot a is equal to minus 3 by 2 is the answer. This is our answer. Right? This is the question number 13. Next 14th question. Next 14th question. 14th question. If either vector a and vector b equal to 0, then a dot b equal to 0. But the converse need not be true. Justify your answer with one example. What they given? Vector a is equal to 0 or vector b is equal to 0. Then a dot b is equal to 0. But the converse need not be true. Justify with one example. What is the converse? The converse of this one, a dot b is equal to 0. Then vector a and vector b need not be equal to 0 is the converse. So you take the converse is vector a dot vector b equal to 0, then vector a is equal to 0 or vector b is equal to 0. It means 0 vectors, not vectors here. Vectors. Scalar. See, so the converse what we are given here, the converse is need not be true. That means a dot b is equal to 0, then a and a equal to 0 and b equal to 0 need not. So that means it need not be equal to a equal to 0 or b equal to 0. You take one example. Vector a is equal to 2I cap plus j cap and vector b is equal to I cap minus 2j cap and you see here the magnitudes are 2 square 4 plus 1 square 1 0 square, so that is equal to root 5. So that means vector a is not equal to 0. First to improve a and b, a dot b first we find. vector A dot vector B is equals to 2I cap plus J cap dot I cap minus 2J cap. So this is 2 into 1 2 minus 1 into that is 1 into minus 2 is minus 2. 2 minus 2 is 0. That is vector A dot vector B is 0. But here, magnitude of vector A is equals to 2 square 4 plus 1. So that is equals to 5. Root 5. That is vector A is not equal to 0 vector. And vector magnitude of vector B is equals to under root of 1 square equal to 1 plus minus 2 whole square is 4. 1 plus 4 is root 5. So vector B also not equal to null vector. You see the converse A dot B is equal to 0, then need not be vector A is equal to 0 or vector B is equal to 0. You can take any one example which product is 0 but A and B not equal to 0. Like when you take any one example, I taken this one. So like this we will do. This is the food into one. Right? Next 15th question. Say 15th question. 15th one. If the vertices A, B, C of triangle ABC are 1, 2, 3, minus 1, 0, 0, 0, 1, 2 respectively, then find angle ABC. Angle ABC, that means angle B we are finding here. That angle we are taking as theta. The theta value we are finding here. You see, the first you write the position vectors of given point. Of the vertices. So that is the position vector of A represented with OA. OA is equals to I cap plus 2 J cap plus 3 K cap. OB is equals to minus 1 into I cap minus I cap plus 0 into J cap plus 0 into K cap. That is equals to minus J I cap. Next OC is equals to 0 into I cap 0, 1 into J cap plus 2K cap. What is the angle theta here? What we are finding here? Angle B, ABC angle. First you find the side AB. That means first of all you find the vector AB. Vector AB is equals to OB minus OA. Right? So OB is equals to what? Minus sign. Minus OA is equals to minus sign. Minus 2J cap C. Minus 3K cap. So this is equals to minus 2I cap. Minus 2J cap. Minus 3K cap. Which is AB. Vector AB equals to. Now BC. Vector BC is equals to OC minus OD. What is the OC? J cap plus 2K cap minus OB is equals to minus I cap. Minus into minus plus, so that is I cap plus J cap plus 2K cap, which is BC is equals to. Now here only you find magnitude of BC. That is 1 plus 1 plus 4, that is equal to root 6. Here AB, so magnitude of AB find here. That is under root of minus 2 square 4, minus 2 square 4 plus minus 3 square 9. So this is equals to root 7. Now cos theta is equals to, again let angle ABC is equals to theta. Angle ABC equals to theta. Then cos theta is equals to vector AB dot vector BC by magnitude of vector AB into magnitude of vector BC. So this is equals to A dot B is equals to first A dot B also we are finding. But I'm directly writing A dot B is saying that is AB dot to BC minus 1 I coefficient minus 1 here plus 1, so total minus 1. J coefficient here, sorry here 2. Otherwise the right ones here. So AB, what is the AB? Minus 2 I cap minus 2 J cap minus 3 K cap dot BC. BC is equals to I cap plus J cap plus 2K cap by magnitude of AB is equal to 17, magnitude of BC is equal to root 6. That is cos theta is equals to cos theta is equals to this is minus 2 minus 2 minus 2 minus 2 minus 3 into 2 minus 6 by root 17 into root 6. This is total minus root 10. Sorry, minus 10. Minus 10 by root 17 into root 6. This is the cos theta. Theta is equal to cos inverse of minus 10 by root 17 into root 6. If theta is acute angle, we are taking positive. If theta is obtuse angle, we are taking minus angle. So here the angle is we are taking minus only, positive only, acute angle only I am taking here, so that I will write plus. Right? Otherwise you can write as a modulus. If you try to recognize a modulus, we are getting modulus of, so modulus of minus 10 only, theta equal to cos inverse. So this is the 15th one solution. Show that the points. 16th show that the points A 1 to 7, B 2 6 3, C 3 10 minus 1 are collinear. This one we are doing collinear. So first you write the position vector. OA is equals to I. Otherwise directly I am writing AB position A vector AB, that is OB minus OA. So that is equals to 2 minus 1 into 2 minus 1 into I cap H2 minus X1 into I cap plus Y2 minus Y1 into J cap, 6 minus 2 into J cap plus 3 minus 7 into K cap. This is I cap plus 4J cap minus 4K cap, which is this one vector AB. Next you find vector BC, OC minus OD. That is here this is x1 y1 z1, this is x2 y2 z2. So 3 minus 2 into I cap plus 10 minus 6 into J cap. Next minus 1 minus 3 into K cap. You do want to here only you find the magnitude. So this is equals to 1 plus 16 plus 16, 32, 33. So square root of 33. So this is equals to 3 minus 2, 1 into I cap, 10 minus 6, 4, 4 J cap. Next to minus 1 minus 3 minus 4 K cap, which is BC equals to. Now magnitude of BC square is equals to square root of 1 plus 16 plus 16. This is also root 33. Next to CA. magnitude of CA or AC, that is AC, as AC. OC minus 2A, OC minus 4A, that is vector AC is equals to 3 minus 1 into I cap plus 10 minus 2 into J cap. Next to plus minus 1 minus 7 into K cap. This is 2I cap plus 8 J cap minus 8 K cap, which is vector AC is equal to magnitude of vector AC is equal to 2 square 4, 8 square 64 plus 8 square 64, and this is equals to 4 12 130. So this one we can write as 4 into 33. So 2 root of 33, which is AC is equal, magnitude of AC is equal. Now AB plus BC, magnitude of AB plus magnitude of BC is equals to root 33 plus root 33. This is equals to 2 root 33. 2 root 33 nothing but AC, magnitude of AC. Therefore, magnitude of AB plus magnitude of BC is equal to magnitude of AC. Therefore, A comma B comma C are collinear. Magnitude of AB nothing but the distance A to B is root 33, B to C is root 33, A to C is 2 root 33. That means A, B, C are collinear, lies on the same line. So A, B, C are collinear. This is the proof of 16th one. Next, 17th question. Next, question number 17. Question number 17. Show that the vectors 2I cap minus J cap plus K cap. Next, I cap minus 3J cap minus 5K cap. 3I cap minus 4J cap minus 4K cap. Form the vertices of right angle triangle. Vertices of right angle triangle. These are the vertices. So the position vectors are OA, OB, OC, right? OC. So here two methods is there. First, you find the vector sides of the triangle. Vectors of sides of the triangle. That is vector AB, vector BC, vector CA, and you find the magnitudes. And sum of the squares of any two sides is equal to third one side square. Then ABC is a right angle triangle. That is the one method. Other method, just you find the vectors, sides vectors. If any two dot product is 0, then those are perpendicular. Means right angle triangle. So second method is easy for me. So I am finding the sides vectors. That is vector AB. Vector AB is equals to OB minus OA. That is equals to H2 that is OB minus OA. Directly right here. Vector AB is equals to, what is that? I minus 2I minus I cap minus 3J minus of minus plus J. So minus 2J cap minus 5K minus K minus 6K cap. This is the vector A. Next, you find vector BC. So that is OC minus OB. OC minus OB. So 3I minus I, 2I minus 4J minus or minus plus 3J, so minus J. Next to minus 4K minus or minus plus 5K, so plus K cap. This is BC side. Next to CA or ABC. So this is OA minus OC. OA is equal to 2I minus 3I is minus I cap minus J minus or minus plus 4J. So that is equal to plus 3J. Next to K minus or minus plus 4K 5K. You see which product is 0? AB dot BC or BC dot CA or AB dot CA. You take roughly you find this is minus 2 AB, these two product minus 2, next to plus 2 minus 6. So this is not equal to 0. If you take these two product, these two minus 2 minus 3 plus 5. So it is 0. So that means BC dot CA is 0. You find like this. First you find BC vector BC dot CA. That is equals to minus 2 minus 3 plus 5. This is equal to 0. Vector BC dot vector CA equal to 0. That is BC is perpendicular to vector BC is perpendicular to CA. Means this is the BC A. This is the A. These are perpendiculars. So right angle where? At C. So here angle CBCA is equal to 90 degrees. Therefore, triangle ABC is right angle triangle. This is the answer. Next, last question in this exercise. 18th question. Vector A is non-zero vector and non-zero vector. If vector A is a non-zero vector of magnitude A and lambda. Vector A and lambda is non-zero scalar. Lambda into A is unit vector. If A is equals to lambda is equal to 1, lambda equal to minus 1. A is equals to magnitude of lambda. A is equals to 1 by lambda. What is that? Magnitude of vector A is equals to A. Understood? Magnitude of vector A is equal to small a. And lambda into vector A is a unit vector. So that is equals to magnitude value is equals to 1. So this is lambda is constant. So lambda into magnitude of A is equals to 1. Lambda into magnitude of A is equals to A is equals to 1. So A is equals to lambda is equals to 1 by A is the answer. Which is the right option? Otherwise A is equals to 1 by lambda. Here A is equal to 1 by lambda option is there. A is equal to 1 by lambda. D is the right answer. So this is the exercise 10.3. So next we have examples. Example question numbers written here 13, 14, 15, 16, 17, 18, 19, 20, 21, 13 to 21. So these example problems you solve. these example solutions I will send in PDF. Once you try those examples, if you didn't get the solution, once you see the PDF. But you have to solve all the examples 13 to 21. So you practice, you try these questions and write in your classworks. So this is the exercise. Next we have only last exercise based on the product of vectors. Which one? Scalar product we finished now. Vector product. Vector product of two vectors we have. So on that we have one exercise. That exercise we will see in next videos. Alright, last exercise.